Welcome to our official lesson on stoichiometry. It's a really nice big word and it sounds like you know something very difficult, but it really isn't that difficult. You know the mole-to-mole relationships within a balanced chemical equations. We are now going to apply that same idea, and we're going to look at mole-gram relationships and gram-to-gram relationships within our balanced chemical equation. So we're going to begin by taking another look at this cheese sandwich with kind of gross American cheese, but it's an easy analogy. We have our 2 slices of bread plus 1 slice of cheese makes 1 sandwich. We have our ratios, 2 bread to 1 sandwich and 1 cheese to 1 sandwich, just like we had our ratios with our moles in the last section. Now we're going to apply some concepts to chemical equations. We're going to do this by looking at an example of combustion of propane. The question is how many moles of oxygen will be required in order to react exactly with 44.1 grams of propane. So here we have, what do we know? We know 44.1 grams of propane. And what do we want to find? Well, here we know this. We want to find moles of oxygen. So let's look at how we do this. First, we take our equation, we make sure it's balanced, and it is a balanced chemical equation. So we're already part of the way there. The first thing we want to do is we want to convert our grams into moles so that we can look at that basic fundamental mole to mole relationship, okay? So remember how to do that. We take our grams of propane and we multiply by the molar mass. Remember our molar mass, 1 mole of propane equals the molar mass of propane in grams, which is 12.01 times 3 for carbon and 1.008 times 8 for hydrogen. We come up with our molar mass of the entire compound, 44.09 grams per mole of propane. And we put the grams on the bottom so that grams of propane cancel out. And we end up with 1.00 moles of propane, 3 sig figs here. Now, once we convert into moles, that was our first step, we will then find the moles of oxygen using our mole-to-mole relationship that we just learned. So let's take the number of moles of propane, we're just rewriting it down here, and we're going to multiply by our ratio of moles of propane to moles of oxygen based on the stoichiometry right here, the coefficients. All right, we know that 5 moles of oxygen is needed to react with 1 mole of propane. Okay, just like our 1 slice of cheese was needed to combine with 2 slices of bread, we have our relationship right here. And the answer, when you multiply that out, is 5.00 moles of oxygen. And that is the answer. So let's see if you can try one of these problems. How many moles of water are produced when using 100 grams of oxygen in excess propane? And I'm going to say 100 grams. So it gives us 3 significant figures to work with. So go ahead and pause the video and see if you can do that one on your own. And I will help you with the answer. Okay, here's our answer. Hopefully you got the right one, but I'll walk you through anyway. We are looking at what we know, and what we know is that we have 100 grams of oxygen, and we want to know how many moles of water is that going to be producing. So we take our oxygen, convert it to moles, so that we can look at the mole-to-mole ratio. When we take oxygen and multiply by the molar mass, the grams of oxygen would be on the bottom, the moles of oxygen on the per 1 mole of oxygen on the top, we get 3.125 moles of oxygen. Second step, we're going to find the moles of water with our mole-to-mole ratio, since we know the moles of oxygen. So we're simply rewriting this number down here. Our moles of oxygen multiplied by the mole-to-mole ratio, 4 moles of water to 5 moles of oxygen, 4 moles of water to 5 moles of oxygen. We put the oxygen on the bottom so that our moles of oxygen cancel out. and we end up with 2.50 moles of water, and that is the answer, with only 3 significant figures. Now, what if we complicate this a little more? What if we want to know the grams of water produced when using 100 grams of oxygen in excess propane? After all, this isn't really that valuable. If I told you to come up with 2.50 moles of water in the lab, you'd probably look at me a little strange and say, I think I'd like to do some calculations and get that into a different unit, like grams. So in order to do this problem, we would simply repeat what we just did here. We would find the moles of water right there, and we would do one more step, convert that into grams. So we're going to take our 2.50 moles of water, multiply by our molar mass. 1 mole of water is equal to 18.016 grams of water. That gives us 45.0 grams of water. Now, you'll notice that if I start with the grams of one of the reactants and I'm asking for grams of the product, I'm going to first convert the reactant into moles, find the number of moles of the product, and then convert back to grams. So it will be 3 steps. You try this problem now. How many grams of carbon dioxide are produced when 98 grams of propane are in excess, are reacted with excess oxygen? So here's the answer. Hopefully you got the right answer, but if not, I will help you out with that. We are going to set this up just like we did before. Here first we have our balanced chemical equation. We want to convert into moles so that we can find our mole to mole ratio, and then we'll convert back into grams. We know that we have 98 grams of propane, and we want to find the grams of carbon dioxide. So that is where we're going with this. We start with 98 grams of propane. We're going to convert that to moles by doing this step right here. 1 mole of propane has 44.09 grams. There is equivalent to that. That's the molar mass. These will cancel. And I'm going to write this all in one big long piece, but you may break it down into 1, 2, 3 separate steps if you like. They're here, 1, 2, 3 separate steps. I'm going to just string them all together for our example. Now, the second step here is that I want to use my mole to mole ratio to understand how much propane is reacting with my carbon dioxide, and I do that in this step. Right there, there's my mole to mole ratio. I put the moles of propane on the bottom so that they cancel out. I now am looking at moles of carbon dioxide, and I want to convert that back into grams of carbon dioxide. So I'm going to go back to my molar mass, 44.01 grams of carbon dioxide per 1 mole. Put the moles of carbon dioxide on the bottom so that those cancel out, and I'm left with grams of carbon dioxide for my units. When I multiply 98 by 3 by 44.01, and I divide all of that by 44.09 times 1 times 1, I come up with 290 grams of carbon dioxide, and I'm limited to just 2 sig figs. So that's why I only put 2 sig figs in my answer. So I look forward to seeing you in class and seeing how you like working some of these problems.